Problem 1421. From question we know that simply supported beam for W is 16 by 36, which is made of A992 steel beam, is subjected to a uniform distributed load of 1.25 kips per foot, and also the point load of 10 kips acting at the center of the beam of span length 24 feet. So as we know, the beam is W 16 by 36. From appendix A, we, we can get the properties of the materials like polar section modulus value, section modulus values, and self-weight of the beam, that is 36 lbs per foot. When we convert from pounds to kips, it is 0.036 kips per foot. So, and we can get the depth of the beam and thickness of the web from the table. Similarly, from appendix G, as we know, the beam is made of A992 steel beam. We can get the tensile yield strength from appendix G. So now we calculate the total uniform distributed load acting on this beam. So we have two uniform distributed loads acting on this beam. One is the superimposed load, that is 1.25 kips per foot, and the other one is self weight, that is dead load, which is 0.036 kips per foot. So the total UDL load acting on the beam is summation of dead load and the imposed load, so which we got as 1.286 kips per foot. So now we check with the moment. So in order to check with the moment, first we calculate the bending moment of this beam, and we also calculate the required bending moment. If required bending moment is greater than the calculated bending moment, the beam is okay. So the bending, we calculate the bending moment by using this formula, where WL square by 8 represents the bending moment for uniform distributed load acting on the beam, and PL by 4 represents the bending moment for the point load, that is 10 kips. So substituting the corresponding values, we have calculated bending moment as 152.6 kips foot. Now we calculate the required bending moment for the beam, which is given by the formula 0.6 SYZX, where SY is the yield strength acting on the beam, that is 50 KSI, and ZX is the polar section modulus, which is 64 cubic inches. Substituting the values and calculating, we got required bending moment as 160 kips foot, which is greater than the bending moment, calculated bending moment. So the beam is okay. Similarly, we check with the shear. So similar to the moment check, first we calculate the maximum shear force acting on the beam, and then we calculate the required shear for the beam, and if required shear is greater than the calculated shear value, then the beam is okay. So first we calculate the maximum shear force by using the formula WL by 2 plus P by 2, where WL by 2 represents the shear force acting on the beam due to the uniform distributed load, and P by 2 represents the shear force acting on the beam due to 10 kips. So substituting the corresponding values, we have calculated maximum shear force as 20.4 kips. Now we calculate the required shear force by using the formula 0.4 SY dTW, where SY is the tensile yield strength and D is the depth and TW is the thickness of the web. Substituting the corresponding values and calculating, we got the required shear force value as 93.6 kips, which is greater than the maximum shear force calculated value, that is 20.4 kips. So the beam is okay.